Hello, this is my team's Progress web application created using Python's Flask library. The goal of this application was to help visualize the progress of the United Nations towards their 17 Sustainable Development Goals. And so at the home page, we have all 17 goals being displayed, and they're displayed using the Bootstrap grid system, which would allow for the content to be very responsive. So if I was to collapse the window, all of the blocks of content would stack on top of each other. So it's very user friendly. And so in the goals tab, all 17 of these goals are further described with a goal description. And all of the goal descriptions are gotten from UN's goal data API. And again, this is also created with Bootstrap Grid. So all the content just stacks on top of each other nicely. And in the Documents tab is supplementary content with links to the 2014, 2015, 2016, 2019 Global Sustainable Development Report. So when you click it, it redirects you to a new tab and links some more information on that. And in the milestones is just a little bit more supplementary content with the United Nations critical milestones towards their goals. And here in the Progress tab is the visualization of each goal. So for each goal, there is an AVL tree created and a minimum heap or a maximum heap. And the goal here is to represent the 10 countries that are doing the worst in each goal. So all of this data is gotten from an API in JSON format. And all of the units are shown right beneath the titles. And there's also a timer right next to the titles that tells you how long it takes for the structure to make this list. So with the AVL tree and the heaps are going to be much faster because to display the minimum or the maximums, it has to be popped 10 times to get this list. While with the AVL tree, it has to have an in-order traversal and only the first 10 are going to be printed. So we have the first goal, the second goal, the third goal, fourth goal, and fifth goal, all printed here. And in each case, we see that the AVL tree is not as efficient as the heap structure. And in the 100K test, 100,000 randomly created country nodes with randomly created poverty data based on the global statistics are made in an AVL tree and a min heap. And again, we have 10 countries displayed that are doing the worst for this goal. And so the performance difference is much more apparent here because there's 100,000 country nodes that it needs to go through. So for displaying the countries doing the worst, the minimums in these values, the AVL tree is going to be much less efficient than the min heap. And finally, in the search tab, we test the search functions for the AVL tree and the min heap. So basically, again, we create the 100,000 randomly generated countries with poverty data. And in this case, the min heap is popped until one country node is left. And the time it takes to do that is the search time for that node in a min heap. Then we take that node and search it in the AVL tree, and that is also time. And in this case, the AVL tree is going to be much more efficient than the min heap for searching. So we see we're searching for the country node 43534. In the min heap, that's going to take around 4 seconds, but for the AVL tree, it's 0, or very close to 0, because the rest of the decimals aren't as close to the answer.